Now coming on next part, next term we are going to define, that is local maxima and local minima. This is the maximum and minimum value we have taken in an interval. Now we are thinking about local maxima and local minima. Local maxima and local minima. Now what is the meaning of local maxima? That was the maxima and minima in the complete neighborhood, in the complete interval. But here we are saying this is maxima and minima locally. Locally means in its neighborhood it should be maximum or minimum. Simple example if I take, if I just think about a district, the maximum authority is with the mayor. Mayor is the maximum authority, or we should say maximum will be mayor of the district. Jaipur district has a mayor, a different one. Jodhpur have another mayor. Every district has a own mayor. If you think about the state, the maximum will be the governor. Governor is maximum in its neighborhood. What that neighborhood will be in that case, that will be the state. Mayor will have a neighborhood, that will be the neighborhood called as district. If you think about the country, the neighborhood has increased in that case. What that will be? President. So in that case, when maximum of the country, I'll say, we will say bigger neighborhood, and in that the maximum will be the president. Second one, when you think about the state, the governor will be the maximum, again its neighborhood but reduced one. Third one, I told you district. District, when you take, then we will say it will be mayor will be the minimum, maximum one. So we will say they are now locally maximum, we can say. Because word if you take, in that country is a small part. So we should say in the neighborhood if you think. First I told you district, that is a neighborhood, small neighborhood. In that mayor is maximum. So mayor is maximum locally in its state, district. Same way governor if you take, it will be locally maximum in its neighborhood. What that neighborhood will be? State. When you think about the country, the neighborhood will be the complete country, and in that case the president will be maximum. So we will say now neighborhood will decide maximum and minimum, and that's why they are called as a local maximum and local minimum. So keep in mind now, when you think about this now, local maxima and local minima means there must be some neighborhood we should define, and in that neighborhood they must be maximum or minimum. So first we are thinking about what is local maximum and what is local minimum. So write down definition of local maximum. A function fx is set to attain, a function fx is said to attain a local maximum, said to attain a local maximum at x is equal to a, at x is equal to a, if there exists a neighborhood, if there exists a neighborhood a minus delta to a plus delta. If there exists a neighborhood a minus delta to a plus delta of a, this is neighborhood, we have neighborhood of a, such that fx comes out to be less than fa for all x belongs to a minus delta to a plus delta, where x should not be a. fx is less than fa for all x belongs to a minus delta to a plus delta, where x should not be a. then x is equal to a is the point called as local maximum. Now what is the graphical representation? That also you should remember. If you take the curve like this is point x is equal to a I am taking. Then first if I take the neighborhood of it means slide interval left side and slide right side. Then this will come out to be a minus delta. This is called a plus delta. This is your FA. In this small neighborhood, if you just think about the function, what you will find, FA is maximum in its neighborhood. FA is maximum in its neighborhood. A minus delta to A plus delta, where it is maximum, it will be maximum at FA. इसके नियर अबाउट जितने भी x हैं सब आपके पास FA से स्मॉलर आ रहे हैं. That means we will say this x is equal to a is point called as local maximum in the neighborhood. Local maximum, why? Because it is in the neighborhood, it is maximum. So we should say this function is said to be maximum, local maximum, if there exists a point A where FA is coming greater among all fx, where x should not be a. This time I am saying x should not be a. जितने भी a को छोड़ के x है सब हमारे पास neighborhood में क्या होने चाहिए? Should be smaller than fa. fa से छोटे होने चाहिए. And if it is taking place, we will call this as local maximum. So what I told you, local maximum means there must be a neighborhood of A, and in that neighborhood it should have the maximum value. Same way when you think about the local minimum, then again there must be a neighborhood, and in that case what I should say, fx should be greater than fa. Then it will be local minimum. So when you think about local minimum, what I should say, first around A there must be a neighborhood, A minus delta to A plus delta, and in that case fx should be always greater than fa for all x belongs to A minus delta to A plus delta, where x should not be A. The curve come out to be like this. This is x is equal to A. It is its neighborhood. A minus delta and then it is A plus delta. And then we will say this will be the neighborhood. In this case, what you will find, all fx are coming bigger than f. ये आपका fa है. All the values which are on left side you take or right hand side you take in the neighborhood, it will be the minimum most. So we will say it will be local minimum. So for local minimum, there must be a neighborhood in which this fa must be minimum. All values of x are coming greater than fa, and in this case what you should say, fa is greater among all x which are between a minus delta to a plus. So it is the local maximum, it is the local minimum. So one thing is clear now, what is local maximum and what is local minimum. Now one more thing you should note here. Whenever there is a local maximum or local minimum in the function, this is the graph I am taking, or you are taking graph like this. One thing you should keep in mind that local maximum and local minimum are always alternate. Local maximum and local minimum are always alternate. Alternate का मतलब ये local maximum है, this is another local maximum, maximum between them one minimum. But keep in mind function should be continuous. That is a must case. Function अगर define नहीं हो रहा है तो फिर कुछ करना नहीं है. But if the function is continuous, then we should keep in mind that maximum and minimum are always alternate. Between two maximum, there must be one minimum. In this case also you can have. It is the maximum case, it is the maximum case. This function is not differentiable. That is the problem we have. Continuity is there, but differentiability is failed because this is the corner point. So, but if it is a continuous, then we should say between two maximum, there must be one minimum. This is again two maximum. If I take, there will be one minimum. So, between two consecutive maximum, there must be one minimum B. Or between two minimum, there must be one maximum. Two minimum, there must be one maximum. So keep in mind, maximum and minimum are always alternate. Now write down necessary condition for local maxima or local minima. Necessary condition for local maxima or local minima. Write down please. Necessary condition for local maxima or local minima. Write down. A necessary condition for FA, necessary condition for FA to be an extreme point, extreme point means it can be local maxima, it can be local minima. Extreme point we call as local maxima or local minima. Extreme point of the function fx is that f dash a is equal to 0. Necessary condition for fa to be an extreme point or extreme value of the function if f dash a is equal to 0. F dash a equal to 0. Now what does it mean? आगे एक और लाइन लिखो. If it exists. If it exists. So what it says that if you have an extreme point means local maxima or like local minima. If the point is a local maxima or local minima, then at that particular point, f dash a must be 0. If it is the point A I am taking, it is the local maximum point, then at that point if you draw tangent, definitely this tangent will come parallel to x-axis, or I should say f dash a is coming through. If it is here, this is the local minima. Again x is equal to a, I am shifting here. Then you find if it is a local minima, again f dash a is coming zero. If you have this is local maxima, again x is equal to a, come out to 0. But one line I have written in last, if it exists, means if the function is differentiable, then only f dash a is come out to be 0. If it is not differentiable, f dash a will not come out to be 0. यहाँ पे आप क्या कहेंगे? It is a local maximum, but the f dash a does not exist. So if it does not exist, you can't say 0. Here it is local minimum, but f dash a does not exist, so we can't say f dash a is 0. Here again it's maximum, but f dash a is not 0. Here also f dash not. So if f dash a exists, we will say if the function is continuous as well as differentiable in the complete interval, then if x is equal to a is the point which is called as extreme point, at that point f dash a must be 0. If by the way it does not exist, function differentiable नहीं है, फिर कुछ नहीं करना. So if the function is differentiable, means continuous and differentiable, then if x is equal to a is a point of local maximum, then we call this as a that at that point we will say f dash a is coming 0. But its reverse is not true. That means at any point of the function, if f dash a is 0 does not mean it is an extreme point. It is a necessary condition but not the sufficient condition. It is a necessary condition. Necessary condition means if the function is having local maxima at a certain point. अगर आपने decide कर लिया कि नहीं ये local maxima है, ये local minima है, then उस point पे आप अगर tangent draw कर रहे हैं, that tangent will be coming parallel to x-axis definitely. But अगर आपसे कहा जाए कि function के किसी point पे f dash a 0 आ रहा है, by the way the curve goes like this. It's every point you draw the tangent. It will come parallel to x-axis. Will it be a maximum point? No. So its reverse is not true. But whenever it is an extreme point, f dash a has to be 0. But f dash a 0 does not mean it's a every time local maxima or minimum. No. That is not sufficient condition. It is only the necessary condition we should give. So this way you will be having local maxima and local minima. I told you they are alternate, and necessary condition I told you f dash a is coming 0. And when you take a local maxima and local minima, there must be some neighborhood. In that neighborhood, it should be maximum or it should be minimum. One, I told you in an interval it is maximum or minimum. Second thing I told you, in its neighborhood it is maximum or minimum. So when you think about the neighborhood, we will say it will be local maxima or local minimum. Next time we are going to come on sufficient condition, and then we will be just going to do the test by which we are checking whether it is maximum or